Good afternoon, everyone. My name is Aaron James, and this is the last and final video for the History of Mathematics class. The topic that I'm going to be talking about today is Pascal's triangle. Pascal's triangle is a number pattern that was named after a French mathematician. His name was Blaise Pascal. Pascal, I don't even know if I'm pronouncing that right. And Blaise Pascal, excuse me. It was named after him because of the innovations that he found by using this particular number pattern. Just a little bit of history about the number pattern. Other mathematicians actually discovered this type of pattern before it was actually termed Pascal's triangle. Um, a lot of people were trying to figure out what they could do with this pattern or what type of answers it would give them or different types of ways that it could help them in regular problems. Mathematicians from India, Persia, Germany, Italy, pretty much a lot of the main people that were interested in mathematics in history that actually have contributions in mathematics were pretty much interested in this number theory. Um, Pascal's triangle is about creating a triangular array of coefficients, being that the top row, which starts with 1, is the power of a binomial expression, since anything to the power of 0 is 1, therefore the first number is 1. The coefficients of the first binomial, let's just say, for example, a plus b, the coefficients a plus b to the first power is itself. So a plus b would be the answer. Therefore, a plus b, the coefficient would be understood as 1 because there is no coefficient there. And therefore, it just goes down in the order, being that the third row being 1, 2, 1. So a plus b squared, it would be a squared plus 2ab plus b squared. This 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 pattern is very interesting to me. They actually have other patterns as far as inside the triangle, which I really didn't know about. Patterns such as the diagonals, the horizontal sums, the powers of the products of the power of 11 is actually the answer in the actual Pascal's triangle, which is actually the coefficients of binomial expressions. The Pascal's triangle is also helpful in computing combinations and permutations. When really in Pascal's triangle, I recognized what Pascal's triangle was even before this assignment, even before the discrete mathematics class that I have with Dr. Jones. The pattern is very similar to Fibonacci sequence, and let me tell you why. Fibonacci sequence is about having basically the sum of the previous two numbers. Now, Pascal's triangle doesn't have the exact same sequence, but it's a sequence that goes into a triangular form. The answer that you get for the coefficients for the next row is actually the sum of whatever those numbers are, and it will be in between the boundaries of having 1 and 1. Just like the first row, for example, the second row, the first row, because the 0th row is technically 1, the first row would be 1 and 1. So the following row would have 1, 2, 1, because the previous numbers 1 plus 1 gives you the sum of 2. Therefore, the sum would be in between 1 and 1 in the third row, giving you 1, 2, 1 as your third row. And as before, the following row, it would be, therefore, if it's 1, 2, 1, the following row would be 1, 3, 3, then 1, because 1 plus 2 is 3, and then 2 plus 1 is 3, because you have to add all of the All of the all of the additions of the numbers must be present in the following row between the ones. Um, Civilizations that actually discovered this formula, Pascal's triangle, pretty much dated back to the 12th century. The Chinese, the Yang Hu, which is Chinese for Pascal triangle, basically created the same type of format. The same type of format that Pascal's triangle is used today. They pretty much called it the 7 multiplying squares. I don't really know exactly where they actually got that from the Chinese, because I really don't know Chinese language or anything like that. Not only the binomial expansions are important when dealing with this, but the patterns that are in the triangle itself is probably one of the most remarkable things of that, being that the diagonals actually have a pattern with the diagonals and the triangle numbers and counting and stuff like that. So it's very interesting to have something created like this in this time. And what's actually interesting is Fibonacci sequence is another number pattern, but the Fibonacci sequence can be found in Pascal's triangle. The sequence pretty much starts with 0 and 1, and then it just continues to add by the previous numbers, just as Fibonacci sequence is. But the difference with Pascal's triangle is the numbers are in a triangular format because of the what the pattern actually calls for, being that the previous numbers are being added and are also being added into the following row of the sum. There also have been different types of triangles. Sierpinski triangle was one. He was from, I believe it's between Italian. I believe it was an Italian mathematician. His philosophy that he had was that the odd and even numbers, you would end up with the same pattern as the Sierpinski triangle by having the same format as Pascal's triangle. When using Pascal's triangle, one can show many ways of heads and tails. I thought that was a pretty cool thing, with the probability of having what will be heads and what will be, heads, tails, stuff like that. And probability probably has to be one of the most important aspects, in math today, I believe, because it can foresee events, things happening, such as trends, using trends and what this person most likely will do, or what this group of people might do. Pascal triangle can be used in a lot of things as far as that goes. Like I said, for example, the probability of heads and tails is definitely a Fibonacci sequence. Being one toss, it could be heads or tails. So that would be the actual first row when it's 1 and 1. The second possible result after 2 tosses could be, heads, heads. It could be heads, heads twice, heads first, tails first, and then whatever the vice versa of that is, and then tails, tails, which is basically 1, 2, 1 in Pascal's triangle. And then that pattern just keeps on going and keeps on going and traverses all the way down until, well, pretty much ever ending until whenever the power is reached, or whatever the number of the binomial pattern is reached. The actual formula that is used to actually help in the entry of each triangle is basically the combination of N, and K. Now, you can simplify this by saying the N factorial over K factorial times N minus K factorial. Now, using this way, of course, using this formula, of course, you would definitely get the same answer. However, when you get to a rather larger number, if you don't really have a calculator or anything like that, that's definitely going to be a pain. Calculators actually have that function, and just simplifying it definitely by just using a combination, that would definitely help. That would definitely make everything more more simple. Another interesting pattern about Pascal's triangle is the triangle is symmetrical. It's if you divide it right down in the middle, it's just like a mirror image almost. The numbers that you see on the side being that the ones are always on the outside entries of the triangle, and on the inside being the sum of the numbers as it traverses down, and it just increases. The horizontal sums of each row is actually a pattern that doubles each time of each row, being that the horizontal of the first row, well, the 0th row will be 1. So then the first row will be 1, 1, which is the sum of that is 2. So the double of 1 is 2. 1, 2, 1. The double of 2 is 4. And then the double of 4 being that the sum of 1 plus 3 plus 3 plus 1 is 8, which is a double of 4. A lot of other patterns that people, not a lot of other patterns, but a lot of interesting things that people see, or people wonder is how is this pattern created? How is this pattern created with the resources and the time that people have? I believe that once the early mathematicians found out what this pattern was, it was pretty much a collaboration where people wanted to find out what they could innovate and what they could find by using this same pattern. After they found out that the pattern does work in many different forms, and even simplifying a binomial expression down by using the distributive property, and law of factorization, pretty much everything is pretty much set. I don't know much more that I can say about Pascal's triangle, being that it definitely has a rich history. I definitely has a rich history of being in other parts of the world, but Blair Pascal was definitely was the soul. It was named after him because he found many of the patterns and many of the innovations that Pascal triangle can be used. Therefore, that he was the one that was credited with that name. However, centuries before, there were other mathematicians that discovered this sequence. However, just without the innovations. Blair Pascal was definitely in the Western Hemisphere. Was definitely known in the Western Hemisphere as being a mastermind. I definitely enjoyed looking at this pattern and finding out more information about it. I didn't really know I heard of it. When I was introduced, to different number patterns and like high school, middle school. Actually, it was like middle school, learning Fibonacci sequence and Pascal's triangle. Pretty much the standard middle school, college algebra classes, things like that. When I took that in high school, middle school, but it's definitely it's definitely something that I had interest in doing, and I definitely like researching about this topic. That's definitely why I picked it, because I was always interested in how something like this would work and how it could be applied to so many different aspects in life. Like I said, just the um, probability and the binomial expressions, and pretty much builds on that. It was very interesting to me, and I'm definitely glad that I did something like that. Um, Pretty much that's my 15-minute mark right there. Another thing that I want to say is the patterns that Pascal triangle has. There are definitely more patterns out there that's similar to that, similar to Pascal triangle and Fibonacci sequence. But Pascal might be one of the most better known ones, just because of the influence of the Western Hemisphere, um, of the Western side of the world, and how they pretty much key the term, and they gave the name the actual pattern after him, after Pascal. So once again, Pascal's triangle, definitely a remarkable number pattern with the resources that they had in those days, and the fact that it was actually discovered before him, centuries before, with more or less resources, is pretty much remarkable. It is pretty much remarkable, and the fact that this actually happened in history just makes it more worthwhile for me to do this topic. So y'all have a good day. This concludes my video. See you later.